So, good morning, all of you. Today, I will take lectures of machine learning, and it's one of the areas of the machine learning that is called the clustering analysis. So, now what is clustering? So, here it is written clustering is the assignment of objects into groups so that objects from the same cluster are more similar to each other than objects from different clusters. So that means that if there are k number of clusters in your data set, suppose we want to allocate the whole data set into a k number of clusters, then the assignment of the objects in each cluster will be the similar objects. That means that the similar characteristics of the objects will belong to the same cluster. That is so clustering is a common technique for statistical data analysis, which is used in many fields. The fields like machine learning, data mining, pattern recognition, image analysis, and bioinformatics. Now we have to go through that what are the different techniques of the clustering. So there are three categories of clustering algorithms. Number one is the partitioning algorithms. Number two is the hierarchical clustering algorithms. And number three, clustering algorithm of categorical data. So today we will discuss about the two methods of the partitioning algorithms. That these are the different types of partitioning algorithms of clustering. Number one is the k-means algorithms. Number two is a k-medoid algorithm. Number three is a PAM, that is PAM, the full form of it is that partition around medoid. Number four is a Clara, clustering large applications, that is called Clara. And number five is the Clarence, that is clustering large applications based on randomized search. So these are the five methods, these are the five algorithms of the partitioning clustering, and we have to go through one by one. So first we have to go through the k-means algorithm. Now what is k-means algorithms? K-means algorithms where each cluster is represented by the center of gravity of the cluster. So whatever be the number of clusters, say 2, 3, 4 or k number of clusters, whatever be, that there should be one particular data or one particular object, we have to fix it as a clustering head or cluster head. And that cluster head will represent the whole clusters. And that cluster head has to be selected on the basis of center of gravity of the cluster. Center of gravity means that we have to consider the mean of the data points belongs to this cluster. So, and another method is the k-medoid algorithms where each cluster is represented by one of the objects. Represented means that it is represented by cluster head, and this cluster head will be the one of the objects of the cluster located near the center. So this is called a k-medoid, that means located near the center. It may not be exactly the center of gravity, but it is somewhere very close to the center of the cluster. Now initial set of clusters, now we have to go through the k-means algorithm. Now initial set of clusters randomly chosen. So we have to, suppose we are having a one data set and randomly we have to choose that the initial set of clusters. That means cluster 1, suppose I want to divide the whole data set into two clusters. So that the representative of the cluster or the cluster head has to be selected randomly at the initial step. Next, iteratively items are moved among sets of clusters until the desired set is reached. Okay, so now after the iteration by iterations, we have to change the cluster head. And how it has to be changed? That whenever that in the first iteration that cluster is formed, suppose we have to form the two clusters or maybe k number of clusters, and suppose that in the first step, first iteration step, say k number of clusters have been formed after choosing randomly the cluster heads of all clusters. Okay, now what happens that after cluster is formed in the first iteration, then we have to take the mean of the data points for each and cluster, for each and every cluster. And that mean will be considered as the cluster head or cluster representative in the second iteration. So that process will continue until the desired set is reached. A desired set is this. What does it mean? It means that whenever there is no change of clusters, at one stage what will happen? Even you can change the cluster head, but the object belongs to all the clusters will not be changed. That means that one data point cannot move to the another cluster. So high degree of similarity among elements in a cluster is obtained. That means similarity in the characteristics, and that similarity has to be measured using the Euclidean distance among the data points. Given a cluster Ki, so that is Ti1, that is the ith cluster, the data point is Ti1, Ti2 and Tin, and the cluster mean, that is the center of gravity that we have to consider as the mean of the cluster, mean of the data points of the cluster, and that is a simple arithmetic mean 1 by m. If m be the number of objects belong to this cluster, and 1 by m multiplied by Ti1 plus Ti2 up to Tin. Now there is an example. This is a simple example. Suppose this is my data set. Say these are the points. What are the points in the data set? 2, 4, 10, 12, 3, 20, 30, 11, 25. Now we want to cluster this data set. We want to categorize this particular data set into two clusters. So whatever the class, how many clusters you require, that has to be predefined. That you have to choose. That, and here I am choosing only the two clusters. So that you have to choose. And then suppose here I am choosing the two clusters. Here this technique is the unsupervised learning in the machine learning. It is called the unsupervised learning in machine learning. And unsupervised learning means that what does it mean? That data is not labeled. So there is a difference between clustering and classifications. Classification is the supervised learning. For example, net-based decision tree, support vector machines, all are the supervised learning. But whenever I will go to the cluster, whatever be the clustering technique, maybe partitioning algorithm, maybe hierarchical clustering algorithm, whatever be, so all will be the unsupervised algorithm. Now, suppose I want to divide those dataset into two clusters. Now what I will do? First, what I told earlier, randomly assigned means. Means center of gravity, who will be the representative of the two clusters, that from here, from those points 2, 4, 10, 12, 3, 20, 30, 11, 25, that first cluster head has been selected, that is 3, randomly I have chosen, and another cluster head I have chosen 4. So here is 3 is there and another is that 4 is there. So these are the two cluster head. M1 is the one cluster head of the first cluster, M2 is the cluster head of the second cluster. Now what I have to do, when M1 is equal to 3, now we have to take the Euclidean distance between from 3 to all those points and from 4 to all those points. Now whichever will be less, suppose I am taking the distance of 3 and 2. So what is the distance? 3 minus 2, that is equal to 1. So, and what is 4 minus 2? That is equal to 2. So which one is less? So 3 minus 2 is less than 4 minus 2. So it means that the 2 is more closer to the cluster head 3. So that 2 belongs to the cluster that is represented by 3, not by 4. So here 3, so 2 has come here. 2 and 3, you see K1, that means the cluster 1, 2 and 3 is there. Now what is the point 4? So 3 minus 4, what is the distance from 3 to 4? That is 1. What is the distance from 4 to 4? That is 0. So that means that the distance from 4 to the second cluster head M2, that is less than the distance of 4 from the first cluster head M1. So that means that the 4, that 4 belongs to the 4 itself is a cluster head, so it will be it is quite obvious that it will go to the second cluster. What is the next one? 10. Let's see. What is the distance from 3 to 10? That is 7. What is the distance from 10 to 4? That is 6. So as 6 is less than 7, so it will go for the second cluster. So here the similarity of characteristic means the similar in the sense that is based on the distance from the cluster heads. Okay. So here 10 is having the lesser distance than M1. So that 10, it belongs to the cluster 2 because 4 is the cluster head, distance from 10 to 4 that is 6, distance from 3 to 10 that is 7. So that means that the 6, as 6 is less than 7, so it belongs to the cluster 2. Similarly for 12, that distance from 3 to 12 is 9, distance from 4 to 12 it is 8. So 8 is less than 9, so 12 belongs to the second cluster. Similarly for the 20 and similarly for all the numbers. So yeah, the first iteration step that the two cluster has been formed. One is K1, the members are 2 and 3, and second cluster is K2, member is 4, 10, 12, 20 up to 25. Now what I will do? Here that the cluster I have chosen randomly, but in the next step I don't have to choose randomly. I have to take the mean of the first cluster, that mean of 2 and 3. That means 2 plus 3 divided by 2, arithmetic mean, simple arithmetic mean, and that is that it is the 2.5. And here I have to take the mean of the second cluster, that means simple arithmetic mean, that is 4 plus 10 plus 12 plus 20 plus 30 plus 11 plus 25 divided by 7. There are 7 number of points divided by 7 and that becomes 16. So these are the new cluster head. That means that the cluster head has been changed for each and every iterations. So here it is 2.5 and first cluster represented by 2.5 and second cluster is represented by 16. Now what I will do? Now I have to take the distance from 2.5. First point I have taken 2. What is the distance from 2.5 to 2.5? What is the distance from 16 to 2.2? That is more than, that is 14. So 0.5 is less than 14. So what will happen? That the 2 will go to the first cluster. Similarly, I will go to the 4. So 2.5 minus 2 from distance from 2.5 to 4, 1.5, and distance from 16 to 4, that is 12. So that is 1.5 is less than 12. So that means that the 4 also belongs to the cluster 1. So similarly, so like that, say for example 10. Why 10 belongs to cluster 2? Because if you take the distance, if you measure the distance, Euclidean distance from 2.5 to 10, that is 7.5. But what is that? For example, if you take the 10, if you take the distance from 16, what is that? What is the distance? Euclidean distance from 10 to 16. That is 6. And 6 is less than 7.5. So 10 belongs to the second cluster. Similarly for the 12, 12 means first you have to compare the distance. So you have to compare the distance from the first cluster head and second cluster head. Which one will be less? You have to put that particular data point into that cluster. So here, if you say 12, if you say 20, for example 20, so what is the distance of 20 from 2.5? The Euclidean distance between 2.5 and 20 is how much it is? It is 17.5. But what is the Euclidean distance from 16 to 20? That is 4. So 4 is less than, say, for example, 17.5. Then, as 4 is less than 17.5, then 20 belongs to cluster 2. So like that in the second step that the 2 cluster has been formed, and you see that the cluster has been changed. Initially it was 2 and 3. Now one more member has been added in this cluster 2, 3 and 4. So like that the clustering has been changed, iteration by iteration. And now again M1 is equal to 3. How M1 is equal to 3? That is the cluster head of the first cluster. So what is the arithmetic mean of 2, 3 and 4? That is 3. Similarly, I have to take the mean. Mean means center of gravity. So what is the mean of those things? 10, 12, 20, 30, 11 and 25. That the mean is 80. So new cluster head has been formed, taking the center of gravity of both the clusters. Now accordingly, this representative of the cluster, again you have to modify the clusters. Let's see. So when cluster head is 3, go to the data set 2. Distance from 3 to 2, what is that? It is 1. Euclidean distance from 18 to 2, that is 16. So 2 belongs to which cluster? That belongs to the first cluster. You see, 2 belongs to the first cluster. Similarly, 3 will be, obviously it will be in the first cluster. 4, definitely distance from 3 to 4 is 1. Distance from 18 to 4, that will be 14. So as 1 is less than 14, so it will go to the first cluster. Now for example 10, what is the distance from 3 to 10? That is 7. What is the distance from 10 to 18? That is 8. So as 7 is less than 8, so that 10 belongs to the first cluster. But in the previous step, 10 belongs to the second cluster. Now 10 becomes the member of the first cluster. Similarly for 12, 20, 30, 11, say for example, if I go to 20 or if I go to 30, what happens? 30 minus 30, what is the distance from 30 to 3? 27. What is the distance from 30 to 18? That is 12. So as 30, as the distance is less than, as the distance of 30 is less in cluster representative 2, so it will belongs to the second cluster. Similarly for the 25, just you look at the 25, for example that here that 25, distance from 3 to 25 is 22, distance from 18 to 25, that is 7, so 7 is less than 22, so that means it will belong to the cluster number 2. Now again, next step, again I have to take the mean, 2, 3, 4 and 10, I am taking the arithmetic mean to find out the new center of gravity, to find out the new cluster head or new cluster representative, it becomes 4.75. Now if you take the arithmetic mean of those things, of the cluster 2, that mean is 19.6. Now that the 2 cluster head has been formed again, 4.75 and 19.6. 4.75 is the cluster head of the first cluster, 19.6 is the cluster head of the second cluster. So again you have to form the cluster, you have to modify the cluster. So 4.75, now we go to the first data point 2. Distance from 4.75 to 2, what is that? 2.75. Distance from 19.6 to 2, what is that? The distance is more. So as this distance is more, then the 2 belongs to the first cluster. Consider the number 11. Say for example 11. 11 belongs to which cluster? Whenever that M1 is 4.75 and M2 is 19.6, take the distance between 11 and 4.75. How much it is? 5.25. Take the distance from 11 to 19.6. What is that? It is 88.6. Okay, so that means as this distance is less, as the distance of 11 from 4.75 is less than the second cluster head, so it will belong to the first cluster. Similarly for the 12. Say for example for the next cluster is 25. Look at 25. 25 minus 4.75, that is 21.25. 25 minus 19.6, how much it is? It is 5.4. So that means that the 5.4 distance, and here it is how much? It is 21.25. So 5.4 is less than 21.25. So that means that particular point 25 belongs to the second cluster. So each and every time from each data point, for each data point which is given in the data set, we have to compare the Euclidean distance from the first cluster head as well as second cluster head. So and whichever is less, that data point will belong to the cluster cluster represented by that cluster. Now again I am doing the same thing, taking the mean, arithmetic mean of the cluster 1, it becomes 7. Who are the members of the cluster 2? 20, 30 and 25. What is the mean? 20 plus 30 plus 25 divided by 8 becomes 25. So 7 and 25. So like that, now you see that 7 and 25. Now if you get 7, again that these things have to be, again that cluster has to be formed again, and accordingly that cluster has been formed. And when I will stop, when that algorithm will terminate, whenever there will be no change of the clusters K1 and K2. Whatever be the center of gravity, whatever be the that means what I want to say, whatever be the cluster head, here it is 7 and here it is 25. 7 for cluster 1, 25 for cluster 2. So whatever be the cluster, head, at one time you will see there will be no change. So if there is no change of the clusters, that means that cluster head will not also be changed. So cluster head, there will be no change, because if there is no change of the cluster members, so that means that the cluster head will also not to be changed. So that means our algorithm will terminate and I will get the final cluster. So here I think that you got the final cluster. Even you take M1 is equal to 7 and M2 is equal to 25, I think that the two clusters will be remain unchanged after comparing the Euclidean distance from all the data points whichever has been given to you. Now this is actually the way I told, I have shown the example that algorithm has been written here. So here that is the data set T1, T2, Tn, set of elements. Okay. Adjacency matrix. Adjacency matrix means that the distance of the cluster head from the all data points in your set, and that has to be predefined. That is the number of desired cluster, how many clusters you want to require. So that has to be given as an input. Adjacency matrix showing the distance between the elements that I told you. That is the distance among this. Now output. What is the output? That output is the set of clusters. K-means algorithms. Here that output is the set of clusters. That means that the ultimate formation of the cluster that I want to say. Here it is K-means algorithms. Actually what is the output has to be given by this algorithm, Assign initial values for means M1, M2, Mk. That is the means, that in the first iteration that we have selected randomly. All the clusters had been chosen randomly. So suppose these are M1, M2 and Mk. K number of clusters that I want to require, and that is given as an input. Now what I do? Repeat each item Ti to the cluster which has the closest mean. Okay. So that the Ti has to be allocated, Ti has to be assigned to this cluster only where it is having the closest. It has been closest among all the clusters. So assign each item Ti to the cluster which has the closest mean. Calculate new mean. Now after the first iteration that you had seen that now how that the mean has to, how the cluster has to be calculated, how the cluster, that is how the cluster representative has to be computed, that is the center of gravity. Center of gravity we are considering as the mean of the all the members of the cluster. It's an arithmetic mean of all the members of the cluster. And until convergence criteria means, so at one point that you will see there will be no change of the cluster set. Whatever be the member in the previous iteration set, that will be unchanged in the next step. So that means it is called it is the termination condition or convergence criteria. So thank you, and we will continue in the next class. After that, that we will start the K-method algorithm in our next class. Thank you all.